Hey everyone, I am Miss Hu, your physics teacher. In this video, I will be discussing the answers to a past year question and then we will compare the answers to the mark scheme. For some questions, the answers will be covered first so that I can explain the thought process of getting to the answers, as you will need to know how to get the answers and not just what the answers are. Then, based on the mark scheme, I'll explain why the marks are awarded as such. Question 6. Figure 6.1 shows a person using a magnetic window cleaner. The part on the outside of the window is attracted to the inside part through the glass window. So you can see this is the diagram shown in figure 6.1. Each part of the window cleaner contains two magnets. Figure 6.2 shows the magnetic field between the parts of the window cleaner. So figure 6.2 shows us a close-up of what the window cleaner would look like. There are two parts. One is for inside the window and the other is for outside the window. Just going to zoom out a little bit so we can see the window cleaner more clearly. So for the inside the window, there's a handle, and inside both parts, there are magnets. And these are the magnetic fields between the bar magnets. So to understand what this question is about, you have to understand how this window cleaner works. So this part on the left with the handle is for someone to hold. And outside the window, this is a part which is equipped with the window cleaner. So how it works is that someone inside the room will be holding the inside component. So the outside component is moved with the magnets to clean the outside section of the window. This is very useful for windows which is not accessible on the outside, for example, high-story buildings. So this is a cheaper and easier way to get the outside of the window to be cleaned easily. Now let's look at the question. A. Glass is not a magnetic material. State the difference between magnetic and non-magnetic materials. This question is not related to glass. This question is asking you to state the difference between magnetic and non-magnetic materials. So it's quite obvious. Magnetic materials can be attracted to magnets, while non-magnetic materials cannot be attracted to magnets. So that's the answer we can write for this question. Now let's check the answer scheme. So here you have a choice of any one of the following. You can say that magnetic materials are attracted to magnets, or you can say non-magnetic materials are not attracted to magnets. In this case, accept either one, because as long as you can state the difference, they'll give you 1 mark. So yes, we get 1 mark. Another way to phrase this is you can talk about the force, because as you should know, a magnetic field is the region where a magnetic pole experiences a force. So magnetic materials will experience a force in magnetic fields, while non-magnetic materials don't experience a force in magnetic fields. So that's why these answers are also accepted for this question. B. Suggest a suitable material for the magnets in the window cleaner. Explain your answer. Now remember that for your syllabus, when it comes to materials for magnets, there's always a choice between two different materials. You can use iron if you want to use a temporary magnet, or you can use steel if you want to have a permanent magnet. So to identify which material to use, you need to look at the function of the magnet in that device. So this device is a window cleaner. You got to consider, do you want a temporary magnet or a permanent magnet? If you use a temporary magnet, it means that the magnetism can be lost quite easily, and then what happens is the outside part of this window cleaner would easily fall off once it's lost its magnetism. So obviously you do not want a temporary magnet. You want a permanent magnet. So that's why we will suggest steel as a suitable material. So not only do we need to suggest a material, we also need to give a reason for the selection of this material. So that's why we need to write the material and a reason. Let's check the answer scheme. So you can see the answer scheme here gives you two options, but in both cases, you must suggest steel. There are two possible reasons you can suggest. Either you can say that it stays magnetized or that it makes a permanent magnet. So as long as you have suggested the correct material with the correct reason, you'll get 1 mark. Question C. Label the poles of the magnets in figure 6.2. So let's look at figure 6.2. This is a diagram which we will need to label the poles of the magnets. So we have bar magnets in both parts of the inside window and outside window. The magnetic fields give us a clue as to what the poles should be. So the fields you can see is traveling from the left to the right. So you need to recall, for magnets, how would the direction of the magnetic field look like? That's right, it's always from north to south. So all you need to do is just label north and south on the bar magnets, like this. So north is where the magnetic field starts from, and south is where the magnetic field ends up at. So if you look at the mark scheme, it just gives you marks for correctly labeling N and S poles, because the examiner obviously would know where N and S would be. So this is correct, and that's why we will get our 1 mark. D. State how the field lines in figure 6.2 show different strengths of the magnetic field between the magnets. Let's look at figure 6.2 and observe what's the difference in the field lines. We can see that the field lines are not all parallel to each other and the spacing is not equal. So some parts of the field lines are very close to each other, while some are a little bit further apart. So how do we tell whether the field is stronger or not? Obviously, the closer the spacing is, the stronger the magnetic field. So that's what we can write for the answer. You need to talk in context of the field lines because that's what the question asks. So I'm going to write here, the smaller the distance between the field lines, the stronger the magnetic field. Now let's look at the mark scheme. So the mark scheme says field lines closer indicates stronger magnetic field, or words to that effect. So in my answer, it is saying the same thing with just slightly different wording. So yes, this will give us 1 mark. Now what if you wrote it the other way? What if you wrote that further field lines indicate weaker magnetic fields? You will still get marks because that's what ORA here means in a mark scheme. ORA means or reverse argument. So instead of stating it this way, you wrote the argument for the opposite. It will still be accepted as long as the concept is correct. So that's how you answer question 6. If you found this video to be helpful, click like and subscribe. And do let me know how you have found this video to have helped you. To watch videos on other questions, check out the playlist on my YouTube channel or on my website physicsrocks.com to find the question that you are looking for. If you have any requests for a particular question, drop your request in the comments below, stating the year, month, variant, and question number. And if I haven't covered that question yet, I will do my best to come up with the explanation video as soon as possible. All the best for your examinations!